Hello everyone, it's a pleasure meeting you all in my mathematics class. This is a differential equation which I am going to solve today. See, this is a Lagrange's differential equation. Given what is given here? M is minus ny plus nx into p plus nx minus lz into q is equal to ly minus nx. This is what we are given, and this is nothing but the Lagrange's equation. This is Lagrange's equation, namely it is pp plus qq is equal to your r, where this p, therefore this is the Lagrange's equation, and here this p is nothing but what? This p is mz minus ny, q is equal to nx minus lz, and r is equal to ly minus mx. So we identify, this is nothing but, this identifies a Lagrange's equation given by pp plus qq is equal to r, where this p and q are nothing but dou z by dou x and dou z by dou y, which we have already seen in many videos, and that this capital P, capital Q and R are nothing but what is I have written here. Therefore, the subsidiary equation is the subsidiary equations are, see, dx by p is equal to dy by q is equal to dz by r. These are our subsidiary equations. Now that is, this implies, what is this? Dx by mz minus ny is equal to dy divided by nx minus lz is equal to dz by ly minus mx. Now what we have to do is, the solution for this differential equation will be of the form u f of uv is equal to 0, where u is a v or some constants. So the solution to this equation, the Lagrange's equation, is nothing but f of uv is equal to 0, where u and v are constants. So we must be able to identify or get the functions u and v, which are nothing but in terms of x, y, z. Now what we do here is that, see, so here we are going to use the method of equating the method of equations and also multipliers to get this solution, to get the solution. Let us see, let us go one by one and find out how this u and v could be got. Okay, now what is given here now? See, so we have this. Now what that we have to do is, we must see, this is dx by this one. Okay, see, we have to see whether this is dx by mz minus ny. So what I do is, I multiply this by x into dx. See, this is equal to, see, I can write this as x into dx plus y into dy plus z into dz. So if you do the multiplication, you see that this will be x into dx will be m zx minus n yx plus n xy minus l zy plus l yz minus xz. So each ratio, using the properties of ratios and proportions, that is, if two ratios are equal, see, it is like this: if a by b is equal to c by d, then we can write a plus c divided by b plus d. So these are all the properties or the rules of the ratios. So what we do is, here we make use of the facts like this, that we get x into d, multiply this by x, multiply this y, that is z. So when you multiply the numerator, you have to multiply the denominator also. Now you do it, what that you will get here is, see, this is mzx, this is minus mzx, these two will get cancelled. So this and this one, this and this. So this gives you x dx plus y dy plus z dx is equal to 0. Therefore, this implies it is, so this is, so if you take the integral, of this, x into dx plus y into dy plus z into dz is equal to, it is integral of 0, which is nothing but what? A constant, Now this is nothing but x into dx plus y into dy, y dy plus integral of y dy plus integral of dz is equal to a constant. So this simply implies, so this is nothing but x squared by 2 plus y squared by 2 plus z squared by 2 is equal to a. This simply implies a constant x squared plus y squared plus z squared, which is equal to 2a. Simply call it as e. So this gives x squared plus y squared plus z squared is equal to a. So this is nothing but u is equal to a, where u is equal to x squared plus y squared. So I am able to get one function like this. So what is that I do? We know that dx by something is equal to dy by something is equal to dy dz. So by using the properties of ratio and proportions, we can write all these equal to, multiply this by what? X. So when you multiply the numerator, denominator also should be multiplied by x. So you multiply x dx divided by x into something, y dy divided by y into the denominator is equal to z, and add them. All these things will be equal to that. When you add, you see that this becomes 0, that is x dx, 0 into anything will be 0. 0 multiplied by anything is 0. So you will get x dx plus y dy plus z dz is equal to 0. If you integrate, the integration of 0 is nothing but a constant. Because differentiation of constant is 0, the integration will be a constant. So you see that this integral value of this 0 will be nothing but, it is integral of 0. So it is like this. Integral of anything is 0. So this is on the right hand side, we can put it as it is equal to, we can straight away write. That is the meaning of that. That is, you integrate a 0, which is the integrate a 0. You see that it has to be a constant, because the differentiation of constant is 0. So integration will be a constant. So you see that you are getting this a. Now you are getting, by this doing the individual integration, you are able to get one relation, which is nothing but x squared plus y squared plus z squared is equal to a. Let me call this as my 1. See, let me call this as our 2. Now, we have to get hold of another v. That is, we have to get v is equal to b. What is that function v? So that our solution can be written. Now, what shall we do here now? So, this is x, see, dx by something. I'll remove this. So this is what we have. Now what I do here is I use. So this is what I have. Now what I do is I will call this as my C. 1. I call this as 1. See, what I will do here is 1 from 1. What I do is I multiply the numerator and denominator. Here I multiply it by x. Actually speaking, I multiply it by x, the numerator, and then add it like this. So similarly, what I will do is it becomes dx by mz minus ny is equal to dy divided by nx minus lz is equal to dz divided by ly minus mx is equal to, so you can write this as what? L dx plus m dy plus n dz. Then you have to multiply all these things, you have to multiply the denominator also by this L into mz minus ny plus m into nx minus lz plus n into ly minus mx. So this is nothing but L dx plus m dy plus n dz divided by, this is L m z minus L n y plus m n x minus m l z plus n l y minus n m x. So this is what we have. Now you see that what happens to this ratio here. So this is nothing but what? So this is equal to L m z minus L m z. These two will get cancelled. Minus L n y plus L n y. And these two will give you what? It gives you L dx plus m dy plus n dz divided by 0. So you see that when you go for a cross multiplication of this simply implies integral of L dx plus integral of m dy plus integral of n dz is equal to integral of 0 will be a constant, will be called as b. I hope that you are able to understand. See, what we do is you go for a cross multiplication and then integrate. So when you integrate here, it is integration of L dx plus integration of m dy plus integration of n dz. When you cross multiply, it is 0, but integration of 0 is a constant. So that's why I am taking this constant as b. So this simply implies integration of this is lx, this is my plus nz is equal to a constant. Now you see that this is nothing but it is like this, v is equal to b, where v is equal to lx plus my plus nz. Call this as your 3. We will call this as our 1. Therefore, what is the solution of this now? So the solution of 1, therefore we have got this 2 and 3. So this 2 and 3 we have got. Therefore solution to 1 is f of uv is equal to a constant. That is f of, what is our u here? U is x square plus y square plus z square. And what is our v now here? Lx plus my plus nz is equal to 0. So this is the solution. So let me go to the next problem. So you see that now I am going to do the second one, namely this question. Identify this. See, what you have to do is, see, you are given 2z, it is minus y into p. See, it is p plus x minus of minus z into q is equal to, take this to the other side, it is minus 2x, then minus 1. See, it is like this. I will write it here. It is minus 2x minus y. This implies 2z minus y of p plus x of minus z minus 1. I write it here. X minus 1 of z into q minus 2 into y minus plus 1 into, here I will write it in this way. So it is minus y minus 2x, so minus 1 into y, it is minus of plus 2 into x. So identify in that way, nothing more than that. Try to identify in this way, that is, this is nothing but 2z minus, this is remaining as it is, so it is minus 1 actually speaking. Yes, here it is 1. And x minus c, nx here in the place of this x, and I want here minus, so minus 1, because here you have got your plus here, so minus 1. And here it is y, so I am writing it as y. And in the place of this, so it is minus c, it is minus 1. So this simply 1. So it is n is equal to 1. And therefore you see that you put it in this way, you can find that what is your L here, see, what is your, this is your m, see, this is your m. And what is your n? This n is n plus 1. And here n is 1. And L is minus 1. L is minus 1. M is plus 2. So we have got this. So on comparison, you will find that this one. Therefore, solution to 2 is